Alright, for section 8.2, now that we learned how to simplify radicals, we're going to add and subtract them. So the most important thing is you really treat it like you would when we were just looking at variables with like terms. As long as we had the exact same variable with the exact same exponent, we were allowed to add their coefficients. I couldn't add this if it was 4x plus 5y, right? Because x and y would be different variables. Well, the radical has to be exactly the same. So it has to be the same root. And again, we're just working with square roots for this course. And what's inside there has to be the same. Sometimes it looks like they're not the same, but after you simplify them, you can get it to be the same inside. So that's what we're going to be working on. So to add and subtract, we have to have, again, the same radicand. And unlike radicands, and if we can't simplify them to get them to match, then we can't combine them, just like I couldn't combine 4x plus 5y. So our first section, these are the same. So 5 square roots of 3 minus 2 square roots of 3, they both have the same radicand. So I subtract 5 minus 2, and I end up with 3 square roots of 3. For number 2, they all have square root of x. So I can do 7 minus 2, which will give me 5. 5 minus 4 is 1. So this thing just simplifies to 1 times the square root of x. Here, number 3, they both have x minus 1 inside the radicand. And even though it's not there, there's a coefficient of 1. So I can do 4 minus 1, which is 3, square roots of x minus 1. Number 4, I can't do it. I can't simplify because square root of 6 doesn't have any perfect square factors, and they don't match. So therefore, you can't simplify that anymore, and it's just 3 square roots of 6 plus 2 square roots of 2. Now, this next section is if you actually can break it down to see if you can get it to match. So the example, they start with the square root of 12 plus square root of 27. These don't match. But they broke down 12 to 4 times 3, and 9 times 3 for 27. They took the square root of 4 to get 2 square roots of 3, so that's where that comes from. And then this gives me 3 square roots of 3. Now the radicands are the same, and we can add, so we end up with 5 times the square root of 3. So we're simplifying like we did in 8.1, and then after we simplify, if the radicands match, then we're pulling this stuff together. So number 1, I'm going to start with 7. 50, I'm going to break down to 25 times 2. 72 is 36 times 2. And 32 is 16 times 2. So here's a shortcut. Once you see how one thing breaks down, you want to check it for the other numbers, because then a lot of times they have these problems set up so that after you simplify them, all the radicands will be the same. So this gives me 7 times 5 times the square root of 2, which is 35. And then I get minus 6 square roots of 2 plus 4 square roots of 2. They all have the same radicand now, so I can do 35 minus 6 plus 4, which is 33 times the square root of 2. Number 2, I can take this 4 out. So the square root of 4 is 2. So I get negative 2 times the square root of x plus 3 times the square root of x. Radicands are the same. Negative 2 plus 3 is just 1. So I get 1 times the square root of x. And you can either put the 1 in front or not. Number 3, I have negative 3. I can take the square root of 16 and get 4. And then for the second term, I can take the square root of 9 and get 3. So I have negative 12 square roots of t plus 3 square roots of t, not 3, sorry. And negative 12 plus 3 gives me a negative 9 times the square root of t. $98 is 49 times 2. So I have 8 square roots of 2 minus 7 square roots of 2 And again, that's going to give me just 1 times the square root of 2, or square root of 2. These next couple, or especially the number 5, it really looks weird, right? But we're just doing some more factoring. 4x minus 4 is 4 times x minus 1. And then for the second term, I can factor out a 9. So I have 9 times x minus 1. So these are both perfect squares. I get 2 square root of x minus 1 plus 3 times the square root of x minus 1. And now I can put them together. And we end up with 5 times the square root of x minus 1. And then the last one here, 500 is 100 times 5. 800. So that is a little bit trickier, right? Because I could do 100 times 8. But that 8 also has perfect factors. So I want to break down further to 100 times 4 times 2. Because this is all perfect squares. So it's really just 400. And the square root of 400 is 20. So I get negative 4 times 20 times square root of 2 here. And this first part is just 10 times square root of 5. Well, this one ends up with a square root of 5, and that one ends up with a square root of 2. So I can't combine them, but I can write my final answer. And sorry, I ran out of space. I don't know if you can tell on my page, but it's 10 square roots of 5 minus 80 times the square root of 2.